So as I said, over here you can make the analogy of two transistors connected like this. We need not to go into much detail of this transistor, why this Q1 and Q2 and how it is working. I will give you the overview as it is there in your syllabus as an overview part. So this is the construction and you can see symbols. So it is a 3-terminal device. It has the 4-layer. Okay, and it is made up of alternate layers of P and N type material. Okay, so you can see the 3 junction as I said earlier, J1, J2, J3. Now you remember there are 3 junctions. Okay, so whenever you will apply forward bias or the reverse bias to P and N type, that is anode to cathode. Okay, so the conditions of these 3 junctions will be different according to the bias which you are applying. And also there is a role of this gate terminal. I will explain you in the coming slide. So the SCR can be worked in 3 modes. Okay, the first we will discuss about the reverse blocking mode. Second, we will discuss about the forward blocking mode, and then it is forward conducting mode. Okay, so we will discuss one by one all these 3 you can say conditions of the SCR. So in the first mode, we are, let's say we are connecting this P type to the negative terminal of the battery and N type to the positive terminal of the battery. Okay, so what happens? This J1 will be reverse bias, same way this J3 will be reverse bias, but this J2 is forward bias. Okay, so J1, J3, these will be reverse bias due to the battery, and J2 will become forward bias due to the condition of the battery. So now what happens? Unless and until you have a clear path, the current cannot flow. So in this mode, the current cannot flow. So SCR will behave same as whichever you are learning in diode reverse bias. Same way the SCR in reverse bias will have very small current that is due to the minority charge carrier, and we will not have any current which is flowing through the SCR in the reverse blocking mode. Okay, so same way as the diode, it is in reverse bias, there will not be current. Okay, so yeah, beyond some limit, if you increase the reverse voltage, what will happen? The breakdown will happen. Okay, and you will have the high current which is flowing through the SCR. So I will explain you through the characteristic like this. So this is our VI characteristic of SCR. Okay, so in VI characteristic, as we know, on the y-axis we have the voltage, on y-axis we have the current. If you observe the reverse bias characteristic, you will have like this. Okay, very minor current, and if you apply the reverse breakdown voltage or more than that, then there will be breakdown same as the diode, as you can observe over here. Okay, so this is the first mode, which is the reverse blocking mode of the SCR. Now coming to the forward blocking mode. Okay, now once we connect the P type to the positive terminal, this anode to the positive terminal, this cathode to the negative terminal of the battery, what will happen to the junctions? Junction J1 will be forward bias, junction J3 will be forward bias, but junction J2 will be reverse bias. Now there is in between, there is one junction which is not allowing the current to flow because it is in reverse bias. So what we can do, okay, so one way is you apply such high voltage that this junction comes in the breakdown region so that the current will flow through this J2 and we will have the overall current flowing through J1, J2 and J3. Another way is you apply some voltage over here on the gate terminal because gate terminal is connected with the P type material. So if you apply some positive voltage over here, so by making this junction more positive compared to whatever the negative voltage it is facing from J1 and J3 side. Okay, हम क्या करेंगे? What we will do is we will apply some positive voltage to the gate so that the junction J2 will become forward bias. Okay, that voltage will be good enough that it will make the junction J2 forward bias in spite of the J1, J3 voltage, J1, J3 junctions, which are already, you can say they are forward bias, but they are offering, okay, you can say negative, you can say reverse biasing to this layers P and N, which are the intermediate layers. Okay, so what we will do is, okay, we will apply some gate voltage so that it can become forward bias. So SCR can be made conducting by 2 ways. One, I said you apply enough higher voltage of the battery so that this junction J2 will be, you can say, breakdown and we will have the current through it. Or otherwise what we can do is we can apply some gate voltages so that the junction J2 will be forward bias. Already J1, J3 will be forward bias and we will have the current through it. Okay, so now if we understand the characteristic, okay, in the forward bias, so as you can see over here, there is a breakover voltage which is written. So that is the breakover voltage which is required to make the junction J2, okay, forward bias. Okay, without applying the gate voltage, just you increase the voltage, you increase the voltage. At one point, the J2 will be breaking down. So that is called forward breakover voltage. So that is one way. After that, immediately you will have the, you can say, large current, which is shown with this pink kind of characteristic over here. Another way is you apply some gate voltage. तो कैसे? एक तो बैटरी ये एनोड कैथोड के साथ तो ऑलरेडी लगी हुई है. So you apply some positive voltage over here on the gate, between that gate and the cathode, like this. So by applying the positive voltage on the gate terminal as shown in this figure, so what will happen? This J2 also will be forward bias. Okay, J1 and J3 are already in the forward bias, so that the current will flow. Okay, so by doing so, we will have the current which is flowing through like this. Okay, you can see this is the gate turn on voltage, the voltage which we need to apply to make the junction J2 forward bias onto the gate terminal. So that voltage, if you apply that much voltage onto the gate, it will be forward bias, and you will have the straight this kind of VI characteristic, which is like linear almost. Whenever if you increase the voltage, the current will increase in that case. Okay, so that is the you can say the way by which we apply the gate voltage, and we start conducting the current through SCR. Okay, so that is the way. Now, once your SCR is into the forward region, forward characteristic, it needs to hold some minimum current to have in the forward region. So that is called the holding current. Okay, so holding current is what? The minimum current required to keep SCR in the forward region. Okay, so holding current is defined as the minimum current to maintain the SCR in the conducting mode. Another way is, okay, like whatever I explained the second way, that is by applying the gate voltage. Okay, instead of battery, even you can apply this kind of pulse. Pulse मतलब ये on रहेगा थोड़ी देर के लिए फिर off हो जाएगा. So by this way you can apply the gate terminal some pulse or some kind of constant voltage, okay, on the gate, and you can make the SCR in the conducting mode. Okay, so these are the ways in SCR can be switched on, or you can say it can be bring to the conducting mode. So mainly SCR that is used in the rectification purpose. Okay, as I said, but it is used for higher applications. In power electronics it is used. Okay, for regulation of the power. Okay, the SCR is used. So this is all about the SCR. I hope you have understood the topic. Thank you.